Good morning, everyone. So it's 9:30 sharp. We're going to start with the second day of presentation. We have quite a big day today. Again, there is really a strong and heavy program. I hope you will enjoy it as yesterday. And it's my great pleasure to introduce to you Dr. OUERHANI for chair for the first session of the day.
Thank you, Stéphane. Let me put my glasses. Passing 50, you start wearing glasses. So, ladies and gentlemen, I'm pleasure and I'm honored to lead this session, education session. We know, we all agree, in fact, about the importance of education in our society, especially in the era of artificial intelligence and ChatGPT and the like. Especially the Generation Z is profoundly digital native, modern learning methodologies and tools how to take this fact into account. Gaming in general, and serious games in particular, has the potential to stimulate students' engagement and interaction with the learning material. While other technologies like ChatGPT, for example, and are intrinsically or intrinsically comprise the risk of inhibiting students' engagement and involvement. Apply serious games to education is probably a way to adopt education science or adapt education science to the new digital era. So today, in this session, we have 4 speakers. The first speaker is Aurélien Héritier. He will present his paper, The Telegame. Unfortunately, I think he's not present physically today, and he will present his paper remotely. So I can ask Julien to do the logistics. Thank you.
Hello everyone, I'm excited to present for game INGÉNIERIE. Developed as part of course called Game Technologies at the University of Applied Science Master's Program in Lausanne. My colleague Jean-Michel, Xavier Cliva and I worked this project during this fall semester. In this presentation, I will give you an overview of the game's context, introduce our development team, explain the goals, fundamental elements of the game, and finally provide a small demonstration of the game. To start, we are 3 master's students in computer science in Lausanne. Our shared background as electronics technician and our academic focus led us to create a game to facilitate learning about logic gates. Given the complexity of this concept, we believed a game-based approach would simplify this understanding. And that is how INGÉNIERIE was born. Let's now meet the team. I am Aurélien, an electronics computer engineer at a company called Digital Logic in Sion. My colleague Jean-Michel is a research assistant at the University of Applied Science in Paris. And Xavier Cliva, a third member, is a full-time master student at the University of Applied Science. The primary goals of our game are to offer an interactive way to learn about logic gates. Player move levers to set state, place logic gates, and solve the logic circuit to open a door. This information is stored in CSV file, which a professor fills out to create a level. In INGÉNIERIE, player interacts with a 2D physical world, solving logic circuits to open doors and progress through the game. The gameplay is straightforward. Solve the logic puzzle and open the door. The challenge comes from understanding the logic circuit and finding correct solution. In this slide, we can see the CSV file on the left filled out by the professor. This file indicates the placement of various logic gates in frame, and it can also provide initial clues to the player displayed at the beginning of the level. Additionally, it specifies which logic gates are available for the player to use, which can be placed in the green space that is representing empty logic indicator on the right signifies whether the door will open or not. Moving to the second level, it involves a simple hand gate. Here the objective is to activate both levers to open the door. Next, we introduce the concept of placing logic. The player discovered that we need to retrieve a logic gate from a chest, place it in the circuit, and manipulate the lever to activate the door. Now, let's look at a more complex level, which showcases how a professor can program the level using CSV file, as shown before. We see the player successfully completing this level. We also introduced the concept of broken levels. Here, there are levels that cannot be manipulated by the player and are pre-activated. In such case, the player will select the correct logic gate on the chest to solve the secret. Here we go. In later levels, we see a mix of all game features: operable levels, broken levels, pre-placed logic gates that need to be placed by the player. We can see that the player successfully completes such level. This is just a preview of what the game has to offer. It's not an exhaustive overview of the game's capabilities, as levels are created by professors, and we can envisage nearly infinite number of these levels. To conclude, INGÉNIERIE serves as an innovative approach to teaching the logic of logic gates. The game is highly adaptable to different skills levels and offers a visual representation of the electricity flow, which can enhance the understanding of logic gates for the students. As for perspective and needs, we plan to introduce a larger map, more straightforward level editor than CSV file to make level creation easier for browsing. In the longer term, we aim to create an automatic map generator to extend game lifespan and build partnership with schools for testing and implementation. That concludes our presentation. Please feel free to reach out to us on our respective email addresses with any questions. Regrettably, we couldn't be present today, and we apologize for that. We wish you a good GSGS 2023, and thank you for your attention. Bye-bye.
Okay, thanks to Aurélien and his team for this work and presentation and perfect. So unfortunately he's not here, but you can reach to him via email and other channels in order to maybe have more information or answer or ask some questions. So now we will move to the next speaker, who will be Elżbieta Ustulka. She will present a paper entitled Learning Java Loops and Control Structures by Moving Ladybird. Elizabeth, the floor is yours.
Hello, so my name is Ella, and this is work I did with Alessandro Spatola about learning Java loops and control structures by playing. This is the first prototype, so it's not yet fully functional the way I would see a game function. I'm at the FHNW, which in English says it's called University of Applied Sciences and Arts, Northwestern Switzerland, and we're in the School of Business. I will talk about that later, how that works. So the background is, I do research and I also most of the time I spend teaching, so I teach Java programming and I teach databases, 2 courses. And the setting is we have master students who do research projects. And this is the course is called MSc in Business Information Systems. So this was Alessandro's work. Teaching currently in our school does not use games for programming. And when I showed this to one of my colleagues, said, "Oh no, we don't need games, you know. We're good enough without that." So basically there is a general perception. When I started doing the previous game, which is shown there for SQL scrolls, also the colleagues were dismissive about this. Yeah, no, we don't need that. We're good enough without that. So basically there is an attitude among teachers that, you know, maybe 20% think that games are good, and the other 80% think it's no use. You know, it's not worth spending no time on that in our school. So we have some people doing games, but they're in the minority. And on the other hand, if you think about the world now, I've just looked it up, and there are about 10 million Java programmers worldwide. And there are also people with other programming languages. The way I learned programming was really the hard way. Okay? The only fun was when your program worked at the end. And that usually took, you know, a day or 2. So having a little bit like fun in teaching, I think has got all kinds of good influence on your well-being and makes you enjoy your course much more. I have got a game for SQL, which is first of all very popular. It's highly used in my course that I teach. I teach a database course every term. And I see in their this year we have increased the number of tasks. We have got now 200 tasks. And this really seems to have a positive influence on the students' mastery of SQL language. So I think by providing more games, motivating them more, that we actually get a higher level of achievement, which is very important in school. I want them to be fully qualified to do their work afterwards. So we're starting with Java with one topic, which is loops. So this is a for loop in Java. A loop is a construct in programming where we do a repetition. We program repetition. So for instance, in this loop, if you look at line 4, it says for integer from 1 to 5, I increase that integer, so I go 1, 2, 3, 4, 5, and then I add that integer to the sum, which is initialized in line 3, and I sum up all the numbers from 1 to 5. And at the end, I print out what is the total, and it says at the bottom, sum total is 15. So this is an easy loop. This is one of the things I teach in that teaching unit. The other loop is a while loop, which is more complex. I'm not going to go into that, but it works similarly. You know, it's like just slightly more conceptually complex. So this is the way we have the game now. We run it on Replit. You can see at the top the address, and it says 12 levels. And the task for the student is to edit lines between, you know, if you look at line 17, I hope you can see the number here. This is the method. This is the method where the ladybird moves. So you make it move. So here, in this version, I just say move to it once, and then stop. So the first green image is this playing field where the ladybird is moving. It's got a mushroom in front of it, and it basically pushes it by 1. And then the second little picture to the right is after the move. And we have got this step and run buttons underneath the running environment. So most of it is still similar like in Eclipse, because this is what was the picture in Eclipse. This is how we program. But in Eclipse, I don't see how that loop works. I don't have any visualization. I just have the code, and I get some output, which I programmed. Here, we can actually move that ladybird. We can do other things to this ladybird, or do other things on the board. So we have got this in Replit like this, 12 levels. Doesn't look very exciting. This needs to be gamified. We have, at the moment, the experiment involved 12 tasks. There was a handout, PDF handout, with 12 tasks that they could do, and the tasks increase in difficulty. And in the game, what the ladybird can do is on the bottom left, so that the actions, which are move, turn left and right, put, leave, remove, leave, and there are also sensors, so the ladybird can sense. Have I got a tree in front of me? I have got a tree to the left, right, I've got a mushroom in front of me, or am I on a leaf? These are the actions, and the game actually was developed by people who teach in I think in those vocational schools, maybe in secondary schools in Switzerland. They have published a small paper somewhere, but there's not really like evaluation how good it is. So my student, Alessandro, adapted that game and put it on Replit because it runs in Eclipse and it's hard for beginners to install and hard to cope with. So we have tried to simplify that. And using these graphics, I think it works quite nicely now. So on the right-hand side, you see the board, you see a Linkbird, and the possible task would be to program, a complex program now it would be, to remove all leaves. So this is like very advanced level, right? If you say, that would be task level 12 or 13, remove all leaves. So the Ladybird, you would program a loop, if you see in front of yourself, if you see in front of you a leaf, go forward, take it, yes, go forward, take it. So we did evaluation in 2 classes on two dates. So this is an example date where I was in last year in October. We have, in this evaluation, we had 14 full-time and 19 part-time students. And there is a paper, which I'm going to show the citations for in a second, for MEGA Plus, Quality Evaluation of Educational Games in terms of usability and player experience. And the plan was like this, so we had an explanation before it started. So if you see on the right, 1745 as, I don't know, maybe I should use that. So we had an explanation how the game works here, and there was a break, because I give them breaks every 45 minutes or so in class. Then they played the game, then there was a break, then they played again, and then there was a questionnaire with the researcher where they could ask questions and stuff like this. And there was a break after that, and then I continued some wrap-up and some more ideas. So the evaluation we did showed that the demographics are unfortunately the way they are. So in this course we had 88% male, okay, age 18 to 28. And then the survey consists of the following things: demographics, usability, player experience, and this is all according to this MEGA, and these are the citations. They're in the paper, so you can look them up if you want. This is the list of questions we had in the questionnaire, so there were 35 questions. And for each of those, Alessandro got the statistics, and I'm going to show now the results briefly. So the first thing was to assess how often people play digital games. Do they play at all or not? So as you can see, 18% in dark blue on the left-hand side play every day, and 40% in yellow play at least once a week. So these are digital games. So I would say 58%, almost 2/3 play regularly. On the other hand, the question was, how often do you play non-digital games? So here it looks completely different. So like 64% say rarely, from time to time, maybe like at a birthday party or something, whatever. So you see there is a big difference. They prefer digital stuff, or they use digital stuff more. Maybe it's easier to use. And then the main finding from that is what level did they get to? They had 2 playing sessions of about half an hour or so, and it seems like level 1 was very simple. You could just write move, 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 move without using any loops, so that was an easy one. There was like move the mushroom 4 positions, so that was easy. So they didn't even bother some of them. They started with level 2, and you can see it likes a Gaussian, more or less, yeah, and a standard distribution here. And there were some who did level 12, and we'll see later why. So this part of the survey was about aesthetics and usability. And you see the color coding on the left hand, on the side bottom, it says strong red is disagree, and then it goes to strong red, green, blue. So you see those areas too here, are like these are the weak points. I think that the game is easy to play, right? So that wasn't quite easy to play for a lot of them. And I think that most people would learn to play this game very quickly. So this is the same thing, So the usability is still a bit weak in this respect. On the other hand, in terms of graphics, the fonts are easy to read, the colors are meaningful, and then the text font and colors are well blended and consistent. Now, Alessandro has a company which is called something like my website or something, my web page, yeah? So he actually has a background in graphics. So he paid a lot of attention to that, and that shows. Yeah, I mean, he's not like a graphic designer himself, you know, but he's got skills in that area, so he managed to do that very well. And here, we've got to see here this 1%, we'll have that, see that later in the comments. So I tell my students, before you come to class, you have to watch the videos, and so videos which explain everything. So this is the book, the slides from the book, and they should watch the video. So here we've got those two few guys who couldn't bother watching the videos before, so they come unprepared, basically. So you see that slide percentage, yeah? Here showing in red. They basically are lazy, are not well organized. Okay, if we have to, if we look at the other questions, so the questions were about the contents and structure. Help me to become confident that I would learn the game. This is like looks fairly green. So this part about challenge, new challenges, the game does not become monotonous, so whether it's exciting, completely gave me a satisfying feel of accomplishment. That also looks good. It is due to my personal effort that I managed to advance in the game. And that's a bit strange question, but I think most of this part, I had fun. In particular here, it's quite strong. Most people had fun. Something happened which made me smile. So these are like emotional and effectiveness judgments from the students. And because most of it is in red, in green is fine. There's here one. The game is appropriately challenging to me. So for one person, it was not challenging at all. It's a program. We had 1 or 2 programmers in class, and they don't always bother coming to class. So the ones who come can then, comment on it. So briefly, second slide, there was something interesting. So this looks also mostly green. The problems appear in some of the issues. There was something interesting at the beginning of the game that captured my attention. So that doesn't look too good. And also, I forgot about my immediate surroundings while playing this game. So the immersiveness is not that great yet. So we still need to do a lot of work. Over the last one, the game has supported my goal of better understanding the loops. That seems to have worked. So they also made some free text comments. They're positive. Most of the cases, except for the software developer. I like the concept, the game was too easy. But the other ones, they say, I enjoyed, I would recommend it, should be part of the course, much easier to learn, very fun, and this one will never prepare for the class. Therefore, I had to revise the chapters about the if and while statements while playing the game. So this is not the way to do it, okay? So next time I'll word them. And this is the summary. According to this methodology, this NEUCHA evaluation methodology, we have a score of 53 whatever. The score classifies that as a good game. In future work, we want to integrate it to make the game environment really like a game. Automated evaluation extends to one other topic, and I like to thank the students for taking part, and Alessandro for doing all this work. So this is, I'm finished, and I can take questions now. Thank you.
Thank you very much, Ella. Any questions from the public? Yes, Stefan. You can keep this.
Thank you so much. Thank you very much. Very interesting. I was wondering, basically you are writing something and then you have this ladybug moving. And what about the opposite? Have you thought of like, I am actually graphically moving my ladybug and I see the code.
Yeah, I mean, you could do that, but there is no one-to-one translation between your action and the code. So, if you say, if you have one thought in French, you can say it in 5 ways So there is a problem of a code like this that would be generated would have to be refined by some AI tools to make it really good style. And I do not think we have yet tools that, we do have ChatGPT and stuff. Maybe we have tools, I haven't tested them, that produce perfect code, but I'm not sure how that works. And the other thing is readability of the code as well. There could be questions about how we do it. So you could go the other way. Now, technically speaking, the point in teaching language like this is that programming languages are developing. So when I programmed, or people programmed 20 years ago, they used lower level languages. There's still higher level of of abstraction in languages. This is increasing. So I think teaching that is actually not bad for the future. And if it gets replaced by AI, that's fine, but there may be still some polishing, integration, refactoring of the code and all that other stuff.
Thank you. Christina?
Thank you for the presentation. My question is, okay, I know that you are focused on basic concept of object-oriented programming, like switches, tests, loops. But what about a little bit more sophisticated concepts? So, for example, how can you see that if you want to teach, for example, inheritance, encapsulation, something which is a little bit more logical, more difficult to visualize?
No idea.
Nice.
I haven't made that up. I have proposed.
Thank you. So I'm not alone.
No, I have proposed two master theses. One to teach design patterns, and the other one to teach students how to use Git. Because these are two other things that are hard, you know, and I think inheritance would be one of those. But I'm sure someone who sits down and does it, you know, if we have games for the basics, people will come up with ideas for games for more complex stuff, I think.
Thank you for the answers. One last question. If not, thank you very much, Ila.
Thank you for this
Maybe
chat.
before leaving, I would like to hand out your presentation. Thank you.
Thanks for listening.
Thank you, Ila, for this nice presentation. And then we go to the next speaker, Cédric Larosière, who will present his paper entitled Learning.
Hello, I am Cédric. I am a software developer for 25 years now. I study mainly mathematics applied to computer science, and I mainly work for a Swiss bank, mainly. So I'm creating a lot of very complex software, but I decided 10 years ago to create some games because it's more fun to develop games. So why I wanted to create these games? It's just because 7 years ago my daughter was born in Zug, a small canton in Swiss, where you have to speak Swiss German or German, and I don't speak German at all. So I decided to create or adapt a famous game to learn German. But how to create a game to learn German? It was a big problem for me. So first, I wanted to try some existing app, so Duolingo, Babel, and Drop, but it was too boring for me, and after just some days, I just wanted to stop it. So I decided to find a better way. For me, the most important was to create first a game, because all previous app was an app, was not a game. So for me, a game must be addictive, easy to play, and you must learn something, at least German or something else. So my idea was to find the best game or downloaded game, and one famous game was Subway Surfer. It's a game downloaded by 4 billion people, so I mean it's for every ages. So I adapted the game, so it's an endless running game, so you have a player, you have to run inside a different world, you have to collect coins, and you have also to avoid some obstacles. So here you cannot see how I can teach or I can learn German with this, just with this screen. You will see in the next screen my idea. So for example here I wanted also to learn English, for example. The idea is that you have your character, you have to run, and sometimes you have a question to be able to collect more coins. you have to reply correctly to the question, and you have also, you can hear the sound of the question to do not disturb you a lot. So you have quel est ton nom, then what is your name for the first time, and after I replace one word randomly in the sentence, and I put 3 different choices on the screen, and you have to click on the correct choice. If you don't reply correctly, you have one more question with one more possibility of answer, and until you don't reply correctly, you have no coins and you have no obstacle. So just if you want to stay attracted by the game, you have to reply correctly to all sentences. For example, in this case, because my daughter now, she's 7 years old, she started to learn mathematics, multiplication, addition, and a lot of things like this. And she loves to play the game just to revise or to learn some multiplication. And the same here, you can hear the sentence in both French, English, or German using a text-to-speech system, and you have to reply to the sentences. Everybody can ask, are you sure we can learn something? So, yes, because I can see I improve my German a little bit. Also, my daughter improved for me his skill in terms of mathematics. And I found this good example from Karin Tripp. It's a mother of 4 children, and they was able to learn the periodic table by playing a battleship game. For me, it was, I am a mathematician, more or less, and I don't know the periodic table. And on the paper, the child was able to play this game and was able to know all values, more or less, at only age of 8 years old, something like this. So for me, it was miraculous. So yes, you can learn a lot just by playing something if you are interested by something. Now, my next step for this one, it's I would like to have the possibility for everybody from a website to have the content. So if you want to learn biology, chemistry, everything. Also, I would like to have a dashboard. For parents, it's very important to know if your child play to the game and how is it in terms of skill, in progress or not progress. And I would like also to create more words and more character to make the game more addictive, like in Subway Surfer. You have a lot of character actually in my games, but it's not enough for me, because I can see my daughter stopping to play after, I don't know, maximum 20-25 minutes. She stopped to play because she cannot earn more coins, more or less. So for me, it's the hand. If you have any question, I will be happy to reply.
Thank you for the presentation. I will propose this for my children to know mathematics and chemistry. Great. Any questions from the public? Yes. Let me. Thank you very much, Stefano. Always helping.
That sounds really good. Is it available to everyone? Where is it available? And do you know anything about the user statistics? Do you get any feedback from people?
Yes, I got some feedback. Actually, I publish only the game on Android, but I removed it maybe 6 months ago, something like this, just to have already some statistics. And I also asked to some teacher in a school where is my daughter to play the game with some student. It's some young student, I mean, and they play the game. I have some return. It's why I decided to remove it, because before the game was more, I don't know if you know, Flappy Bird games. So you have a bird, you have to go down and up only. And my first prototype was like this, and it was too much complex for young people because you need a lot of accuracy more or less with your finger. So I decided to change completely the gameplay and to create more this left and right only game, because it's really much simple. And for my wife the same, she's not a player at all. She ate everything like mobile and game, and it's the same. She prefers to play this kind of game instead of Flappy Bird style. So it's why I removed my game. But I think to publish again the game with the dashboard, with the website, with everything, so everybody will be able to play the game.
Thank you, Cédric. Other questions? Maybe I have one. Why the choice of endless game? Is that, do you have any objective, pedagogical objective behind endless, or just like this?
I tried several gameplay of game and to try to adapt the possibility to teach something, and it was always a nightmare to fit more or less the sentence inside the environment. And I found the headless style game was the best choice. And like I said, the Flappy Bird was too difficult. So for me, it fits correctly, perfectly, the kind of learning process. And I am a player, so we have a lot of kind of game. But this one, I think, fits perfectly the teaching process.
Thank you very much, Cédric. Applause again. Huh? And I have your certificate for presentation. Thank you very much. Yeah. So let's move to the last presentation of this session. The presentation is entitled "The Biases of Artificial Intelligence," and will be presented by Biljana Folleriter-Saudi. The floor is yours. Yeah.
Okay. Can you hear me? Yeah. So my name is Biljana Folleriter-Saudi, and I will be talking to you today about a game we developed and that helps to learn about artificial intelligence. So, raise your hand if you haven't interacted with an AI in the last 6 months. Oh wow! Raise your hand if you haven't heard about AI in the last 6 months. Okay. So, just yesterday there were at least 5 talks that mentioned AI, and AI is pervading our lives. In the conference proceedings, the overview has a really nice essay about AI and the precision of vocabulary. Do read it. And basically, we believe that the key to successful coexistence with artificial intelligence is education. Whether you're super excited about AI or super scared, you do need to understand how it works so that you can evaluate, you can assess the risks that are associated with AI. So what are the challenges in AI education? First, well, there's a very rapid development of AI, and all the AI experts agree, which is quite a miracle, I suppose, that experts agree on something. And so they agree that they're all surprised at how fast progress has been made in this field. So this progress is definitely not reflected in the development of AI literacy in people or at school. The second challenge we face is that our target audience is high school students. So AI is notoriously difficult to understand. Like the technical details are really out there. And how to explain AI to high school students? They're not computer science experts nor maths experts. By the way, this game, there's nothing specific about high school in it. We aim at high school students, but you can definitely play it. It's really for everyone. And finally, there's a need for teacher training. So experts of AI among teachers of computer science in high schools, the number is growing really each year, but it still remains relatively low. So even teachers need training about AI before they can talk about AI to their students. So we started basically by our very first starting point was, what are the learning outcomes? The questions we asked were, what do high school students need to know about AI? What are the must-knows? What is it? So we thought that the very first and main thing they need to know is how AI works, or how AI may not work, because it does not always work, and that is an important message. So that is related to one of the shortcomings of AI, which is data bias. Another relevant learning outcome we identified was the societal bias. And this is something you hear about a lot in the media. It's covered by the press. So basically, the third one was filter bubbles. Why filter bubbles? Is because AI encapsulates our students in filter bubbles. So the idea is to show them how they can form and why is it important to know that they exist. So if you're not familiar with these terms, I really suggest you should play the game. One thing I want to insist on is that we do not want to just get a basic understanding of the phenomenon. We want to go beyond the what. We want to go to how they arise. So we want students to know what mechanisms create these biases, create these filter bubbles. And why is that? I truly believe that it is this kind of deeper understanding that allows to have well-argued discussions and that empowers people. It's difficult to discuss about something you don't understand. So the inspiration for our game comes from this game, The Wisdom and the Madness of Crowds, by Nikki Case. So by playing this game, we had like an eureka moment, and it's a beautiful game. So if you don't know it, I highly recommend you playing it. So our game is online, so that it can be played in computer science classrooms that have internet, and it lasts about 20 minutes. We also subdivided the game in 4 chapters, so that each chapter can be played as a shorter session, as a warm-up, as an engaging warm-up to a lesson. So what's the gameplay? Basically, we put you in the shoes of an AI algorithm. So for about 20 minutes, you are the algorithm, and you need to make decisions. In pedagogy, we have the ZPD, which is the Zone of Proximal Development in students. It just means that you need to be somewhere where the students are able to learn something with some guidance. And so we had to simplify the concepts of AI to enable learning. It basically means that our pedagogical approach consisted of just simplifying AI. So what is AI? How does it work? AI captures the statistical structure in data. In its simplest of forms, capturing the statistical structure of data just amounts to counting. So in this game, we ask you to count and to make decisions. And through a very carefully designed scenario, we make you make errors so that you experience the data bias. In another chapter, we introduce plant-loving clouds. And through this scenario, we make the players take racist or sexist decisions. And this helps you to realize where the bias comes from. Why are all these algorithms biased, sexist and racist, and the press is full of them? So the nice thing about this is, for a while we were very, we've been thinking about these issues for years now, and it was a really hard problem to talk about these sensitive issues. It's gender-related, race-related, and we didn't want to hurt anyone's feelings. So it was really difficult to go, explicitly on this subject. And going through this metaphor, using this metaphor, it's really helpful to help students identify. It does not single out a particular race, or it doesn't specifically, it names things, but in a very, very careful way. Okay, so to see whether the game works, we did 2 questionnaires, one before playing and one after playing. And so there is a glimmer of hope. 80% of the teachers say they do know how AI works. When we talk about the main shortcoming of AI, which is the AI biases, this number drops to 2/3. So 2/3 of the teachers have heard of AI bias. And finally, if we talk about filter bubbles, it's less than half that have heard of filter bubbles. With students, these numbers are a bit lower, obviously. So 1/5 of the students think they know how AI works. A little less than this number, but the majority of the students have heard of AI bias, and it's only 1 student in 10 that has heard of the term filter bubbles. Our post-questionnaire, the main result is that 3 out of 4 players feel that have learned enough or a lot. So bear in mind that the number of responses in the post-questionnaire is smaller than the number of responses in the pre-questionnaire. However, when the number of students saying they know something about AI increased from 22% to 72% after playing the game. One teacher even said about filter bubbles, he said, "J'ai appris ce que c'était, merci." So he basically thanked us for teaching him what filter bubbles are. So we asked then the players to grade us, so they gave us grades, and the teachers were nicer to us, so they gave us a 5.4 out of 6, which is traditional in Switzerland, and the students gave us a 4.9. So you can see here that the teachers were always polite, so even when they did not like the game, they gave us a passing grade, but the students were not a standard. So we got a 1.5 and a 2, and by analyzing the results, basically, we did frustrate some players. In the game, you always have to take a decision between 2 choices, and in some cases, the players felt like neither response corresponded to the one they wanted to give. So they felt quite frustrated and wanted to say something else. And this is really related to the main criticism we had for our game, which was kind of the lack of interactivity. And this balance of content delivery and player action is quite difficult to get, because we do want them to learn a lot of things in a short amount of time. When asked about the main take-home message, which is, so the last chapter asks us a question about whether algorithms can make mistakes. This is our main take-home message: is AI algorithms can be wrong. It's not always correct. You don't have to trust the machine. So basically, this number went from half of students in the beginning that thought that algorithms were never wrong, and then this number after playing, there was only 1 single student who still believed that this is true. However, for the other concepts, the learning was not as efficient. It was always more than half, but it was not as efficient as for the main take-home message. So we need to also kind of work to increase the learning. And finally, our students, some of them have never touched the mouse. So they're really more into mobile phones. So we definitely need to try to make our game more mobile friendly. So to wrap up, our game has been played by over 500 teachers and students. I do believe that the hype around AI helped us quite a bit. The experience is enjoyable and the learning is effective. And if you want to play the game, this is the QR code to the website. Although, try to not play it on your mobile phones, please, because it's not as nice as on a tablet or on a laptop. If you have any suggestions, questions, do email me. I'm sorry I have not included a QR code for my email address because it's quite long. But thank you for your attention.
Thank you, Diana, for this very nice and rich presentation. We open now the session for some questions. There is one.
Hi, thanks for the talk. I was wondering how you intend to tackle this issue with neither option being satisfying to the students.
It's a difficult question because the interface is quite small, so it's really hard to have. So maybe have something like. So some students were basically like, I don't want to. Why do people need to be subdivided in women and men? You know, it's difficult because we have a population that is that has some percentage of gender fluid people. And at one point, maybe there should be some kind of disclaimer or something like saying, we do understand, you know, this is very simplifiable. We are aware that this is not exactly what you would expect, but for the purpose of the game, you know, maybe just try to be understandable. Like, just to make them aware that we understand it's not on purpose and it's not because we don't care, might kind of ease up the frustration. I hope.
Any further questions? I have one. Which of the biases that has been maybe where the students progressed most in identification, in knowing those biases, racism, sexism?
So it kind of feels like there were some population students for whom it worked better than for others, because the numbers are quite similar. So it's more like some were willing to learn, so they kind of got it all, and then the other ones were less willing to learn, so they kind of not got it all. So it's very similar numbers across like all the other, it's around 60% in all the other concepts.
What are the biases that you implemented or you showed or you tried to teach?
It's really the data and the societal one. Yeah, we identified those as the more as the largest shortcomings of AI. Like
Societal, you have racism, sexism, and any further biases?
No, it's really we talk about one is a racist algorithm and a sexist one, and then another one which is both.
Okay, great. Yeah.
But no, we did not. Obviously, you can go on different.
You can extend it.
Yeah, for sure. But it's very sensitive. It's difficult. It was difficult for us to approach this subject.
It's critical, yeah.
Yeah, it is. And the population. I mean, you know, this age is a bit fragile as well.
Yes.
So it's sensitive.
But I think you should pursue and insist. Yeah. Thank you very much. Huh?
Thank you.
Thank you.
Thank you.
This one.
Thank you.
Thank you very much. Yeah. So we come to the end of this session. Thank you very much for your attention, your presence, and I hope it was enriching for you and you learned something from this interesting talks and presentation. Thank you very much.